Hey, how's it going, guys? Today in this video, we're going to be going over 7.3, day 3. We'll talk about applications of actually dividing polynomials. So we're not going to go over number 1 or number 2 in this video. It's just not relevant to us. So we're going to skip these two, and we're going to go straight to number 3. So on number 3, we're told the total number of dollars donated each year to a small charitable organization as follows the trend D of t equals 2t cubed plus 10t squared plus 2000t plus 10,000, where D is the dollars and t is the number of years since 1990. So essentially, D of t is just telling us how much was actually donated to this charity. And then we're told the average number of dollars per donor can be expressed by t plus 5. So each donor will donate about t plus $5. And what we want to do is write an expression describing the total number of donors N of t each year. So N of t is the number of donors each year. So if the number of dollars, the average, sorry, read this again, but if the average number of dollars per donor is t plus 5, and N of t is the total number of donors, then I can say t plus 5 multiplied by N of t will give me my D of t, the total amount donated. If you want to kind of put this back into real numbers, let's say I have the same scenario where there's an organization where $1,000 were donated. So let's say there's an organization, $1,000 were donated, and they said on average, each donor donated $10. So I can say, if I want to know how many people donate to this organization, I can say, all right, so on average, each person donated $10. I don't know how many people there are, but I do know that $10 multiplied by the amount of people that donated should equal the total amounts donated. So in this case, N of t, I can get that by dividing 1,000 by 10, when I'll get 100. And I'm describing this because this is the exact same thing we're doing right here for this problem. It's the exact same thing. It's just we have polynomials and expressions rather than just straight numbers and dollar signs. It's the same exact thing, so we're going to do the same thing. I'm going to divide D of t with my t plus 5. Or in other words, I'm going to divide total amount donated by the average amount each person donates. So I want D of t divided by t plus 5. It says that t plus 5 is in the form x minus a. It's in that same form. I can just use synthetic division here. I can use synthetic division.
Please pardon the interruption. Spartans at this time, 10th grade boys should report the tax of the Miller Career Technology presentation. Teachers, please ensure that you take attendance. And boys, you're going to bring your belongings. Gentlemen, you have about 5 minutes to get the tax and be seated. Please make sure to socially distance yourself by leaving a seat in between you and the person next to you. Thank you.
Okay, the announcement was going to happen, but we'll continue on this problem. So D of t divided by t plus 5, where a would equal negative 5. So I can do synthetic division with this a term. So a will be negative 5. So that's in the top left corner. And I'm going to list out my coefficients of my D of t. So in this case, 2, 10, 2,000, and 10,000. So I'm going to do synthetic division with this problem. Obviously, just dividing it, right? Synthetic division is another way to do long division. So bring down to 2. 2 times negative 5 is negative 10. Add going down gives me 0. Negative 5 times 0 is 0. Then I get 2,000. Negative 5 times 2,000 is negative 10,000. And I get a remainder of 0. So this makes sense. It's saying that t plus 5 is a factor of my D of t. So it's saying I have a full number of people who are donating. So I don't have any remainder. All right. So in this case, my answer would be 2t squared plus 2,000. You can factor out a GCF if you want to, but you don't really need to. You just leave it like this, and this is going to be my answer. All right. So we'll go on to the next problem. On this one right here, on number 4, we're told the volume of a rectangular prism is modeled by the function v of x equals x cubed minus 8x squared plus 19x minus 12. And we're told v of 1 equals 0 and v of 3 also equals 0. And we want to identify the other value of x, which v of x equals 0, which will give the missing dimension of the prism. So this problem is using both the remainder theorem and the factor theorem that we learned in the previous video in 7.4 day 2. Remember the remainder theorem? That's telling me that if I have something like this v of 1 equals 0, that's telling me when I do synthetic division with v of x, when a equals 1, I get a remainder of 0. That's what it's telling me. Right? It's the same thing. We're just kind of using it backwards than we did in the previous video. It's the same thing though. So when a equals 1 and I do synthetic division with a equals 1 on v of x, I get a remainder of 0. And also what the factor theorem says is that if I have a remainder of 0 after I do synthetic division or really any type of long division, that means that polynomial, that binomial, whatever you used, is a factor of the other polynomial getting divided. The divisor is a factor of the dividend. That's what it's saying. So in this case, what this is saying is that x minus 1 is a factor of v of x. That's what it's saying. And it's also saying the same thing for this v of 3. Since v of 3 equals 0, that 3 is telling me that when a equals 3, I get a remainder of 0. Or when I put it in the form x minus a, or x minus 3, that's going to be a factor of v of x because I get a remainder of 0 when I divide v of x with x minus 3 or x minus 1. So that's what it's saying. And now that we need to figure out the other dimension is, what we need to do is we're going to factor this out. I need to know what all my terms that will turn this equation into 0 will be. So what I can do is I can divide v of x with either one of these two. It doesn't matter which one. They're both going to give me 0. We're just going to do what we did yesterday. We did in the previous video where we divide the function by a polynomial and we start factoring out that way. So I'll use 1 because it's a little simpler. List out my coefficients: 1, -8, 19, and 12. I'll drop down the 1. 1 times 1 is 1. -8 plus 1 is -7. I made a mistake. It should be -12, not 12. Sorry about that. 1 times -7 is -7. 19 plus -7 is 12. And 1 times 12 is 12. Add going down, we get a remainder of 0. So I already knew you get a remainder of 0, but what I wanted to know was this right here. This is what I needed to know. All right. So from here, because I have a remainder of 0, what this is telling me is that when my a value is this, is a 1, or whatever factor I get with an a value of 1, so in this case x minus 1, I can multiply that with my quotient of x squared minus 7x plus 12, and that'll give me my original polynomial of v of x. So what I can do from here is I can keep factoring out this x squared minus 7x plus 12. So the good thing here is that I already know that the one other factor of this polynomial is going to be x minus 3. I already know that. So I need to figure out what this last polynomial is going to be. I need to know what x squared minus 7x plus 12 is going to factor out into. So I can draw my x. My top is my a times my c. So in this case, 12. And the factors of 12 that add to give me -7. And since I already know this -3 will be one factor, the only thing I'll multiply with -3 to give me positive 12 is -4. So that has to be the other factor. So x minus 3 times x minus 4 gives me x squared minus 7x plus 12. And x minus 1 times that x squared minus 7x plus 12 gives me my original v of x. So this is the completely factored form. And that's also telling me that my x can be 1 or 3, which we already knew. And the missing term we didn't know was 4. So x equals 4, or we can say v of 4 equals 0. Either way works. It's saying the same thing. All right. Anyway, guys, that's the video. Hopefully that helps. Sorry about that announcement in the middle of the video. Did not expect that to happen, but hopefully this was helpful.